So this question, we have two planets, or two stars. One of them is traveling in an orbit like this, and the other one's traveling in an orbit like this. These two stars are traveling around their mutual center of mass, which is here, which is what happens in space when there are two bodies revolving around each other. And we want to know, when will they be at their greatest speed? Well, the greatest speed is sort of like when we have the sun and the Earth. We have this very exaggerated idea of what goes on with the orbits, but with this exaggerated piece of orbits, what we know is we have potential energy out here, we have kinetic energy here, and that's because the velocity is the greatest when it's closest. It's closer, it means greater force, means greater acceleration. Centripetal acceleration means greater velocity. So we want to know when they are the closest. If we start mapping those out, let's see, 1. And then we compare that to 2. Well, 2 is definitely better than 1. So 2 is the worst. So that's out. And 2 is better than 1. And when we look at 3, 3 and 1 are equivalent to each other. And when we look at 4, boy, that 4 is very small. Clearly 4 is less than 3. So it looks like it's position 4. 1 and 3 it could be 1 and 3 if 4 weren't one of the given spots, but 4 is a shorter distance than either 1 or 3. And we know they're not moving at constant speed because they're in elliptical orbits. You know, Kepler's third law, the first one, is the orbits are ellipses, with 1 at the focus. Kepler's second law is that the period squared over the radius cube of the orbits is a constant for a system, and Kepler's third law is about equal areas in equal times. Choice B.